Today's video will explain the prototype design pattern. Hello, I'm James Helfrich. The prototype design pattern allows us to make a copy of an object. This is usually done through the assignment operator and the copy constructor. This video will define the prototype design pattern, will demonstrate how to implement it, and give some best practices how to use it. So a prototype is a mechanism to facilitate creating copies of an object. And this can be done with an explicit method like clone. And so for an example, if I like to make a copy of a Porsche 911, then I just call the clone method and it will return a brand new Porsche 911. Here's an example of a prototype. I have a problem where I have an abstract data type representing the notion of a set. And how am I going to create a copy of a set? Now notice the underlying data structure of a set is a binary search tree, which has a collection of nodes that are connected by pointers. So I can't just make a copy of the first pointer because then I'll have two objects pointing to the same collection of nodes. So instead I need to do what's called a deep copy. So I need to make an explicit function to this copy. And so the solution is I'm going to use the prototype design pattern. I'm going to overwrite the assignment operator, and the assignment operator will take the pointer to the first node and make a copy of it, and then take all of its children, make a copy of it, and so on, and I'll do a recursive copy. When I'm finished, I will have a brand new BST, which I'll then assign to the new copy of set. Now, notice that this assignment operator functionality is non-trivial. There's a great deal of code used to copy it as a binary search tree. And this code, of course, makes sure that all the pointers, the child nodes, are correctly set. And so because this is non-trivial, I need to have my own method, and the prototype design pattern encapsulates that. I'd like to give a few examples of the prototype design pattern in use and not in use. So the first, I'm going to have a two-dimensional game, and this is going to have a position type. And the position is going to have a default constructor, which will make the position 0, 0. It'll have the assignment operator, which will copy the location from one position onto another one. And it will also have a copy constructor. And so both the copy constructor and the assignment operator are examples of the prototype. And the implementation of the assignment operator is quite simple. I just take the member variables x and y, and I assign it to my own member variable, and then I return star this. Many languages, including C++, will generate an assignment operator for us if I don't do it explicitly. But because I'm going to need to copy the position from time to time, it makes sense for me to explicitly implement the assignment operator. Here's another example. This game has a notion of a ground, and there's one and only one instance of a ground for this game. Notice I do not have an assignment operator. I do not have a copy constructor. All I have are just regular constructors. And the reason for this is because the ground is never copied, I want to explicitly not have the prototype design pattern. The next example, also in C++, is the game of chess. And this game of chess has a move class, and that's going to represent how I move a piece from one location to another, including special things like en passant and castling and promotion. Now, I am going to want to put this move object into a stack for an undo stack or a redo stack, or maybe even just record the moves that I've played for save. So therefore, I'm going to want to make a copy of this. And sure enough, I do in fact have a copy constructor, which just calls the assignment operator. And then I have the assignment operator. And this is what it's actually going to do the copying. And so when I go into the assignment operator implementation, we'll see that I take every member variable and I explicitly copy from the right-hand side to the left-hand side. So this is an example of the prototype. Now, once again, back to the chess example, I have a board. The game will only have one and only one board. It is instantiated when the game is begun and is destroyed when the game ends. I will never make a copy of a board. Therefore, I simply only have a constructor for the board. I don't have a copy constructor, and I don't have the assignment operator. Thus, I'm explicitly not implementing the prototype design pattern. So when you want to use a prototype? Well, first and foremost, whenever the client needs to copy an object. When an attribute of a class are trivial, there is no need to write an explicit copy code unless if you want to make it clear to the clients that a copy is allowed for this object. When an object is never copied, such as a pass by value function parameter or whatever, then there is no need for the prototype. And I gave a couple examples of that previously. In just about every other case, the prototype design pattern should be employed, which makes the prototype perhaps the most commonly utilized design pattern of all. Use the assignment operator and copy constructor if your programming language supports it. If a copy needs to be made for an object, you should make sure to implement the assignment operator if your language supports it. All programmers understand the assignment operator. And if your language supports the copy constructors, then implement it by calling the assignment operator, because we don't want to make an unnecessary duplication of any code. This is example 39.5 in the prototype section of the object creation chapter in the software design textbook.